Hi, good afternoon, everyone. As you can tell, we're sitting today, so we're trying to switch things up a little bit and make it a little bit more informal. So, thank you for joining the live, and this is Critical English, Grade 7, and we have our Grade 7 students with us. Azaria, give them a shake. By now, you should know her name, and we have Alicia. Give them a shake. And if you haven't seen the live before, my name is Miss Monique Sarias, and I'm going to be having a nice discussion with these girls. So today's topic, as you can see on the screen, is sorry, I'm mixing my C's up. Comparison and contrast. So this is one of the literary devices that can be used in a variety of settings. And when you're in primary school or nursery school or so forth, a lot of times you talk about it, opposites, right? Antonyms. So if I give a word, I want you to tell me what the other word is, the opposite to it. So I'm going to come up with some random words, and you're going to see who can get it first, right? Straight. What's the opposite? Straight? No, we're not rhyming, we're giving opposites. Straight. If, for example, if a road is straight, what is the opposite of straight? Curled or benny or something like that, right? Or bent. Yes. What about, I'm going to give you an easy one now. Opposite of white? Black. That's an easy one. Opposite of short?
Tall.
Opposite of dung?
Up.
Upside down. That's a hard word, right? Usually, this is not exactly the opposite, but usually people compare a circle to a square. They say you can't put a round peg in a square, something like that, right? Good. What about narrow, like a narrow road? Wide. Okay, so I give you a few. Let's come up with some Azaria, and then we're going to see if we can find the opposite to it. You can probably think of two, and you can give us two, Alicia. It's a hard task to do. Alicia, anything for you? Okay, love. Hate. Good. So we pretty much know what antonyms are, right? And we can give the examples offhand. What about synonyms, or words that are similar in meaning? I'm gonna give you one, and I want you to give me the Guyanese version to it. So you know somebody is fat, but what's a similar word to fat? Chubby. Good. Or somebody is skinny. What's a Creole term for it? What do we call them? It begins with M. Mago. Have you heard that one? Mago? So, yeah, a usual one is if you're skinny, they call you mago. So they're words that are, so you know words have different meanings, right? Some words, when you use them, you already know you're talking about synonyms without somebody saying this is a synonym. And some words are antonyms without somebody having to tell you these are antonyms. So tell me about comparison and contrast now. If we're talking about comparison, then we're doing what? Compare. Good. So that the root word for that is compare. So if we're comparing something, can we just compare one thing by itself, or do we have to match it with something else?
Match it.
Good. So we need to compare things. And on this table here, I have a phone and I have a computer, right? Mm-hmm. So if I'm comparing these two, I'm going to be talking about what? Technology. So they're both of them are technological devices. So that's a similarity between them. About color now, what about the color? They're both black from the screen. From this part here, you're seeing that they both look black, right? Similarity again. Can I do some of the same things on the computer that I can do on the phone?
Yeah.
Yeah. Can you? What are some similar things I can do with the phone and the computer?
You could go on Google.
I could Google things. So we were Googling something just now, right? You want to tell the audience what we were Googling, Alicia?
We were Googling on the oldest secondary school again.
Good. So Alicia had a question. She was wondering what was the oldest secondary school in Guyana, and I googled it on the computer, but I could have also used the phone to search for that, right? So that's the similarity between the two of them. Give me another similarity, Azaria.
You could pair them together.
I could pair them, so whatever I'm seeing here, I can see on this, or whatever I'm hearing from this, I can hear from the other one, right? Excellent. Now let's come up with differences now. What are the differences
You
between?
can't call.
Good, I can't call. Can't I call at all, or can't I use calling for some things? This has a number, right? This doesn't have a number, so I can call direct numbers with this. But
Yeah.
can I make calls on the computer too without a number?
No.
No? Ever heard about online school? How do people go on to online school?
Oh, they.
What they have? Where do they go?
Google Meet.
Google Meet, or there is also Zoom, and there's also Microsoft Teams. So even though it's not exactly a calling, sometimes when you log into these things, it operates the same way a call would operate. Except that instead of talking to one other person as a regular phone call would be, you're logging in to see multiple persons. And sometimes it's still called a call, or sometimes people call it a meeting. So it can be either things. So you can do similar things, but like different features sometimes. What about, can I put both of them in my pocket? So which one can I put in my pocket?
Your phone.
My phone, because it's smaller, right? Why can't I put the computer in my pocket?
It's too big.
It's too big, so I'll need a really, really big pocket, right? And the pocket might be the size of a bag. Good. So that's the difference with it. Any other difference you can think of, and any other difference you can think of, Azaria? Between a phone and a computer.
Phone has WhatsApp.
The phone has WhatsApp. I can get WhatsApp on my computer too.
Yeah, they can make calls though.
I never tried making a WhatsApp call from the computer, so I'll try that when I go home. Anything?
You can get Messenger.
Messenger. I am not sure if you can get Messenger. Never tried. I know you can get Candy Crush though. Anything?
Okay. One of the setup, wait.
Take your time.
Oh, like the apps and different devices, they may have a different setup.
Good. It's the same app, but it looks different on the devices, correct? Good. So there's Microsoft Word, and you may usually use this for schoolwork and assignments, and so where you type your assignments. Do you type your assignments?
Yeah.
You type as well?
No.
You write.
Yeah.
Good. So which one of these would be a better tool to type your assignment on, a computer or a phone?
Computer.
Computer. But can you do it on your phone too? You can, but it's just a little tedious, right?
Yeah.
And it's much easier to text if you're on a phone than to text using a computer. Let's just assume there was a feature to text, right? Good. So we talk about differences, we talk about similarities, we talk about synonyms, we talked about antonyms, we talked about comparisons. So comparisons, when you're comparing two things and you're just looking at both the similarities and the differences, but it can also mean that you're comparing them and you're looking for the similarities between things. What is another word for similarity? I want to make it easier so whoever's listening to us, they can understand what we're talking about. Maybe a younger child or somebody who don't really know what the word similarity means.
Oh,
It means something similar in meaning.
Alright, so when we're defining words, we don't want to use the same word. So it's similar in meaning, yes, but what does similarity mean without using the word similar? Any guesses? No?
alike.
Alike. Good. That's a good way to put it. So if we're talking about similarity, we're talking about what makes these two things alike, or same is not the exact word I'm looking for, but similarity, they're similar, or they resemble each other, or they're almost alike. If we say they're same, it means that they are exactly alike. So you have twins sometimes, and if they are identical twins, they both look the same, have the same height, the same hair texture, the same eye color. And there's some that are not identical. They may be very similar in personality, but they look different. Do you know why there are some twins who look alike and some who don't look alike? Do you know what makes that difference? Have you thought about it before?
Two twins that look alike mostly don't like the same thing.
The same?
Thing.
Yeah, but what makes them not look alike? Or what makes them look alike?
Eye
Right?
color.
Yeah, but like, what is responsible for that? Because they're born this way, right? They're born resembling each other, and those that don't resemble each other are born like that as well. What is responsible for that? What is the science behind it?
How they were created. Maybe they're created.
How they were created. So remember, they were in their mother's womb before they were born, right? So there's some twins, you call them maternal twins, and I think the other one paternal twins. Forgive me if I'm wrong, but this is basically how it happens. So you have the egg, right? When the egg is fertilized by the sperm, so you have a fertilized egg now, and this egg starts to separate into two. So it keeps separating all the time, and then that cell is a cell basically. It develops into an embryo and then becomes a baby, and then that baby grows up to become a person. So what happens in the first instance is that this single cell divides itself into two separate cells, and then these two cells start to develop on their own. So they started from the exact point, the same genetics they have, the same contribution from the mom, the same contribution from the dad. So basically they were formed from the same egg and the same sperm that was divided in two. So they are the same. Because not each sibling would resemble each other, right? That's because each egg is different from the other one, and each sperm is different from the other one. So it depends on which two reach together. I know we're talking a lot of science there, right? But it's connected to what we're doing, talking about similarities, right? And twins, and so being similar and so forth. Now, the ones that are different now, these are ones that were formed with two separate sperms. And I think, I may be wrong, because I don't know everything, I think they also may be two separate eggs. Or it could be that one egg was fertilized at the same time with these two sperms and then split in half. So you have the same contribution from the mom, but two different sperms mean that you have different genetics in the child. So maybe one may be a little taller, one may be a little browner, one may be a little, I don't know, curly hair or something, right? Or one may have one side blue eye, one side brown, and the other one may have both brown. I'm not sure how that works, but something along those lines. So remember our topic again, right? Similarity, differences, comparison, contrast, what makes something similar, what makes it different. Now let's talk a little bit about contrast now. So if we're talking about comparison is both similarity and differences, or sometimes only similarity, when we're talking about contrast, what alone are we talking about? Remember, when I'm comparing something, I'm looking at both the similarities and the differences, or I can look at just the similarities. So if I'm talking about contrast, I'm talking about which one? I can't be talking about both because that's already comparison, right? So what is left for me to talk about now? Only what?
Contrast?
Think of similarity and differences. Which one does it match? All right. Think of it like a Venn diagram. You do Venn diagram in school, right? In math? No? You never did Venn diagram?
Yeah.
Okay, good. So think of a Venn diagram. In one of the circles, we have similarity. In the other circle, we have something. I'm not going to tell you what the something is. But in the middle of these two circles, you have similarity and differences. So the similarity alone is known as comparison. The similarity and the differences in the intersection is known as the comparison. So what's the third one called?
Contrast.
Contrast, and that only talks about differences. See how we use a math concept to get English across? How cool was that? Were you picturing the Venn diagram in your head? Kind of. Alright, so what I'm going to do, I know the audience wouldn't be able to see this, but I want you to draw that in your books. So we're looking at similarity, differences, but the name of the circles are comparison and contrast. So you're going to draw that for me, and as you're drawing that, we're going to come up with our other topic coming up here. So comparison and contrast is actually one of the persuasive devices that we spoke about earlier. You guys remember that? So when we're talking about evidence and so forth, and examples and so forth, repetition even is a persuasive device. So comparison and contrast is also a persuasive device. We also talked about main ideas and how to create main ideas and then build supporting sentences. Remember that too? Good. So as you're working on your Venn diagrams, I want you to think about a topic that you would like to present on for next week. And instead of me doing the talking, each of you will be given 5 minutes to talk about this topic. And you have to persuade me to agree with what you're saying. So Alicia, is there a topic you have in mind? I'm going to give you one, and you're going to try to see if you can come up with something similar. So I know you're in Form 1, but if you are in grade 6, what are the grade 6 students across the country right now receiving in the morning? Breakfast. Would you like to have breakfast in the morning too from school?
Yeah.
You're thinking you wish you were in grade 6 still?
Not really.
Not really. All right. So let's say the topic was all students in public schools should receive breakfast. Would you go against that topic or would you support that topic?
Support.
Both of you will support it. So let's say you had to give a speech on that now. You now have to convince me as to why it's a good thing. So you have 3 points. And remember, we know all these different persuasive devices, right? So, Azaria, what is one device you will use to convince me that this should happen for everyone?
Since most of the children come to school early, they don't get breakfast at home, or they don't get to pack breakfast, so they don't get to eat as often.
So they skip a meal basically, right?
Yeah.
For example, Azaria travels from
The
East Bank to Georgetown every day, and you have to wake up very early, right? So, and Alicia, you also have to wake up early for school?
Yeah.
Good. So if you have to wake up early for school, it means that there's not much time. Maybe your parents make breakfast, but you don't have the time to finish eating it. So you're using, that would be what device there? You're persuading me using an example, right? You give an example there. So I want you to make a note of the word example. So what's another device you can use, Alicia, to prove to me that I should agree that breakfast should be given to all public school students? You want us to help you with some persuasive devices?
Yeah.
So we had emotional appeal one time. We did comparison and contrast just now. We talked about things like metaphor, simile, and use of data like research, or use of authoritative voice like a doctor saying something, or maybe a minister saying something. So which one of those would you like to use? Data. So write down the word data. So the first one is example, second one is data. What data will you try to use to convince me that this should happen for all students?
Because
what data would be available to you?
The way persons may not be able like food may not be able to be provided to different persons, and by giving out breakfast in the morning will help with that.
Yeah, but how do you know the figures or the numbers of the persons who are not getting breakfast? Because remember, data usually refers to numbers. Do you think we can have like access to some kind of numbers there? For example, do you know the amount of primary schools in Guyana? Can we find that information though?
Yeah.
Yes. So if you can find out how many primary schools there are in Guyana, you need to now find out how many students are in grade 6. So let's just assume, I know they're all not getting it right now because they're launching it at different schools, right? So let's just assume that they have given breakfast to all the schools. You now have to multiply, let's say a class is 30 students, multiply 30 by the amount of primary schools that you have, and you get the total number of students who are benefiting from this. So that could be one form of data to say how many persons are benefiting from it. That's one. The other example for data could be those who are getting the breakfast, how do they feel about it? So that is, you can get that data from the students themselves. They can say, oh, this is a good thing, or I love the breakfast that they're giving to me, or this breakfast is filling, and I feel more energized in the day. You think you can get that kind of data from students too?
Yeah.
Do you know any grade 6 students who's getting breakfast right now? No.
Well,
So you,
actually, yeah.
yeah. So have they said anything about the breakfast to you?
No.
No, they probably don't want to share with you, huh? Good. So that's another form of data you can get from these students. So your use of data will be the students who are getting it, how many students are getting it, and what are they saying about it, what are the thoughts of it. And that will work something like a review. For example, if you buy from Amazon, for example, anyone who buys stuff on Amazon online, Azaria? Or shop?
Your mother?
Your mom. Have you ever seen those reviews that they have on Amazon for things that people buy? So they will say whether this thing is a good thing or not a good thing, right?
And the rating.
And the rating, good. So that same rating from Amazon can work like your students. They can rate it. You can ask them to rate it from 5 if they like it, 5 stars, or if they don't really like it, 1 star. And if you just ask about 3 students in your area, then you can talk about students in your area, because obviously those students can't represent the whole country, right? But you can say, based on your knowledge of persons in your area, this is the trend. So if that's happening for your area for just students at grade 6, it is possible that other students from the other grades can benefit too, right? So how does that sound? Solid?
Yeah.
You think you'll be able to convince somebody using that? All right, so we have example there, and the next one was data. So you can write down data as well. You have example written down too? Or just make a note of it as well. And the third one, what is the third device we will use? Is there any way we can use comparison and contrast here? Were you ever in grade 1 and 2? I know it's a dumb question because you were in grade 1 and 2, right? So that's a rhetorical question. Remember that device too? So the other question is, do you remember what it was like getting juice and biscuit at grade 1 and 2?
Yeah.
And nobody else was getting.
I still used to get in grade 6.
You used to get in grade 6 too?
Yeah.
Really? You guys are lucky. Wasn't that cool though?
Yeah. When the teachers have leftovers,
They bring for you guys. Oh, they liked you guys. So the other thing is, if you're using comparison and contrast, it could be because you have gone to school when you were getting snacks, the breakfast and the juice and the biscuit, and you have gone to grades where you weren't getting, right? So how did you feel when you were getting, and how did you feel when you were not getting? Let's have Alicia first, and let's have Azaria.
I felt really good because when you used to get the juice, you used to carry home on Fridays. You carry home you have for the whole weekend. Some days they would give you 3 or 4. And then when I started not getting, I felt like if it wasn't fair.
You felt it wasn't fair because you're still going to the school and you're seeing students with their juice and biscuit, and you probably regret not being in those grades too, huh? All right, Azaria, let's hear from you.
It used to feel nice because sometimes the teachers is bring extras for you to take, with extra juice. So we normally it's like 6 in a packet, so we have several to eat.
And if you're an only child, all for you, right?
Yeah.
But if you got brothers and sisters, you may have to share with them, right? Did you ever get tired of it or so?
Nope.
Well, good. So that's comparison and contrast. So you're comparing when you were getting it, how you felt, and you're comparing that to when you weren't getting it and how you felt. So do you see how comparison and contrast can be used to make a point? Or think about a phone. Let's say you want to convince your mommy to get a phone for you. Not a cheap phone, I don't want to call brand here, but a fancy phone. A smartphone. What are you going to tell her? Using comparison and contrast. Because right now you don't have a phone, so you know what it's like not having a phone. So you now need to compare. If you had a phone, what you would be doing. So let's hear. If you had a phone, what would you be doing?
I'll be on my phone all the time.
But will mommy want to hear that? No. So what will you tell her to convince her to allow
I
you?
need the phone because for me to connect with my friends, I need the internet.
Yeah.
As well as getting the school's homework done.
Homework, exactly. And I think she will more fall for the homework one, right? What about you?
Probably for something similar to what Azari said, using apps for educational.
Yeah, exactly. And she will be like, oh, my girl is so bright, I'm gonna get this phone for her so she will do good in school, right? So you're using comparison and contrast there to convince your mom to get you a phone. Because the two examples you use, connect with your friends, and the reason why you're connecting with them with the phone is because you can't connect with them without the phone, and you can't get as much schoolwork done without the phone as you would with it, right? That's comparison and contrast. So let's decide on our topic now for next week. So the topic that I had just now was all students in public schools should receive breakfast. So that was my topic. And you just spoke about it, right? So come up with a topic that you would like to talk about next week. And if you can't, I'm going to come up with one for you. Same goes for you. So think about it, and then we have to wrap this session up because we're strapped for time. All right, give me a word and I will help you form the topic.
Diabetes.
Diabetes. All right, what's your word? Which subject area do you want it in?
I don't know.
You don't know. So for the one with diabetes, one that I'm thinking about would be because remember you get this from using a lot of sugar, right? So my topic to you will be students should be sold less aerated drinks at their school canteen. I'm going to write it for you. Students, and you'll have to bring in the diabetes part, right? So students should be sold, you have to convince me of this, right? And you have 5 minutes to talk about this. Sold less aerated drink, aerated drinks at the school's canteen. Remember, you got to give me 3 points as well, right? Using the persuasive devices. Azaria, your topic. Can't think of one. All right, let me give you one. I'm going to give you one about sports. You said you don't really like sports, right?
I like.
You like sports? All right. So I'm going to form it. Self-defense classes should be taught at school. You know what self-defense is?
Yeah.
Somebody come and they're trying to hurt you and you just beat them up and run away. Good. So you can defend yourself in case somebody comes, right? And as girls, sometimes we have to be a lot more careful, because sometimes people are bigger than us and they're stronger than us. So let me zip them up before I give you more ideas, right? So you need to come up with how many points? 3 points, and the points you're going to be using persuasive devices to convince me and the audience next week that they should agree with you, right?
Yeah.
So you can either agree with this or you can disagree with this. But if you disagree, you have to say why you're disagreeing. If you agree, you have to say why you're agreeing. Any questions? So 5 minutes, and you will go in front there and do your talking, right? All right. All right. Thank you so much. So we're going to be wrapping up here. And thank you so much for joining us. And next week, please look out for our girls doing their presentation. They will have 5 minutes each, and we will be telling them what points they got right. So looking forward to see you next week. Say bye.
Good afternoon, everyone. Welcome to Critical Math, grade 6 to 7, or we can say grade 7, because our students are currently in grade 7. And so we'll continue our concept as it relates to algebra. So remember, previously we looked at evaluating algebraic expressions. And so today we are looking at algebraic equations, all right, how we solve for those. So let's begin. So our concept today is algebraic equations. And so to get an idea of what an algebraic equation is, right, it's an equation which contains at least one unknown. All right. Now there are many types of equations. You have numerical equations that you're familiar with. All right. So numerical equations involves numbers, strictly numbers. All right. So an example of a numerical equation. All right. So what makes the difference between an equation and an expression is that with an equation you have the equal sign, right? So if I have 3 plus 7, that's a numerical expression. And so if I put that equal sign in there, I have an equation, right? So a numerical expression would be, all right, 3 plus 7. So that's a numerical expression, 3 plus 7. And likewise, if I have an algebraic expression, I'll introduce a variable. All right, we have a variable, x plus 7. That's an algebraic expression. So we can move from an algebraic or from a numerical expression into a numerical equation, and from an algebraic expression to an algebraic equation. Right? So here I'll have x plus 7 equals some value. Equals to some value. So that's the difference. So in an algebraic equation, you have one unknown, right? You can have at least one unknown. You can have more than one, right? You can have more than one. So more than one would make the equations different in terms of, you see later on as you go higher in math, right? Whether it's linear or quadratic or nonlinear, all right? So the most of what you're going to focus on are linear, right? Linear equations. All right, so now that we have an idea as to what an algebraic equation is, we can formulate, algebraic equations so you can represent them. So for example, just like initially when we examined algebra, when we were using symbols, right, to represent the ideas being set out, right? So when a certain number, so I have an example here. When a certain number is increased by 4, the result is 5. Sorry, the result is 9. So you have a sentence there. So do we know what the certain number is? When a certain number, we do not know what the certain number is. We said a certain. So we're not sure what that number is. So is increase. What do we mean by increase? In terms of operation. Am I adding, subtracting, multiplying, or dividing?
Adding.
I'm adding. So if I'm going to increase the number of chairs in the room, it means I'm adding, right? I'm adding to the set of chairs that we have in the room. The result is 9. So how would you represent that as an equation? So we do not know what the certain number is, so you replace that certain number with a
letter.
A letter. And what we call a letter? There's a special name for the letter. It begins with V.
Visible.
Variable. Right? So the special name for the letter is variable. So we'll introduce a variable here. So remember, so the keyword, so the certain number. So the certain number, we let that be represented by a letter. We can use X or A or B. So let's use X. Increase increased by 4. What does that mean? I'm adding 4, right? I'm adding 4. And then the result is 9, so it means something is equal to 9. All right? So initially, I'm going to have x, which is increased by 4, plus 4 is equal to 9. So that's my algebraic equation. So you take it from a word statement and you're representing it mathematically. You can follow that example?
Yeah.
Wonderful. So let's check. Suppose I have 3 times a certain number is equal to 8. How would you represent that in mathematics or algebraically? 3 times. Do we know what the number is? No, so we let a variable represent that number. So what variable do you want to use?
Y. Y.
Y, good. So we're introducing y. So what is happening to y? 3 times,
Y.
right? So 3 times y. So times means multiply, right? So 3 times y equals to 8. All right? So this can be written a little better by 3y is equal to 8. Right? Remember I told you last time that the multiplication sign is hidden between, is understood. That you're multiplying the 3 by the y there. Think you follow?
Yes.
All right. So to master the concept, let's check on another one. 1/4 of a number is equal to 5. 1/4. So, what are you thinking?
We
Multiply
do 1/4 by the variable.
Multiply the 1/4 by the variable.
And you'll get 5 when you multiply it.
Mm-hmm. Yes. When you multiply those two, then what? It is equal to, it's right there.
5.
It is equal to 5. So what is the number? What you're using to represent that unknown number?
What's your
A variable? And so what is the variable this time? Just use any letter.
A?
A. So 1/4 A is equal to 5. So you see in the previous one, right? Notice the language 3 times, right? So in here it said 3 times a number. And times we multiply. Here we have 1/4 of a number. So multiplication is also the language here, right? 1/4 of a number. So the of signifies multiplying. So you see how many words you can use for multiplication, right? Times, of, and sometimes you may say a word product as well. Right? So different words for multiplying. Great. So a number decreased by 4 is equal to 9. Good. Again, we have an unknown number. So what is our variable? Any variable? Come on, Azaria, your turn to choose a variable.
Z.
Z. So Z, what's the decrease by 4 mean?
Divided.
So increase means adding.
Adding.
So decrease means,
Minusing.
which is right, which is subtracting, which is the opposite. So Z minus 4, and that is equal to 9. Right? So look out for the various, right? So decrease, sorry. Decrease, you're subtracting. Or some people might say take away, right? You can say take away. Increase, you're adding, right? You're adding. Any question so far? All right, so let's use some other language here. A number divided by 3 is equal to 8. A number divided by 3 is equal to 8. Write it down in your book, how you interpret it. A number divided by 3 is equal to 8. So what do you have? Okay, so what you have, Azaria? Not yet? All right. At least you're not finished yet either. Okay. Come on. So what is the number? What variable did you choose for your unknown number?
J.
What did you use?
J.
J. What did you use?
T.
T. All right. So T divided by, what is the number that you're dividing the unknown number by? 3. Good. So T divided by 3, and that is equal to 8. Right? So you should have something looking like this. So you may write J divided by 8. Sorry, 3. J divided by 3 is equal to 8. Anybody wrote it like that?
Yeah.
Or you could have written it like this. J divided by 3 is equal to 8. Same thing. All right, so you can either use the division symbol, right? Or you can use the bar, which represent division as well. All right? Okay. So that brings us to, so in our previous session, we were looking at evaluating algebraic expressions. And so what happened was that we had different variables taking on different values, right? So for example, we had, if given a equals to 2, find a plus 5. Remember? We were looking at some of cases like that. So where a was, we were putting the value 2. So we were replacing a with 2. So 2 plus 5. So our result was 7. So in this particular scenario that we're going to have here, in terms of the equations, for example, x minus 2 is equal to 7. So here we have the unknown, and we want to find the unknown, and we want to know what value now is x taking on to make our equation balance, right? So in terms of equation, the left side, so this is our left side, so the left side equals the right side, or the right side equals the left side. So we're trying to find what value must x take on so that the right side equals the left side. So that is what you're doing in terms of when you're solving an equation. All right, so to bring out that concept, we're going to look at we're going to use our tiles. And so the blue tiles are our positive tiles. All right, so these tiles are going to represent our unknown variable. So one of these blue tiles would be an x. Right? That would be an x. And we're going to use the red here. So these are our negative tiles. All right, so take some negative tiles. Just take some negative. I'm going to put some positive ones here as well. So we're doing a little representation of our equation, and we're using tiles. So the tiles will make us use the inverse operation method. All right, so this is what is going to happen. So remember, so one of the blue tiles will represent the unknown variable. So we have 1x, there's an x there, right? So you put 1x there, one variable, one of them, close by. Great. Now we have a minus 2. So with a minus 2, one of these would represent, so if you put 2, that's a minus 2. All right? So we have a little separation here. So on the right side of that, you have 7 positive blue tiles. 1, 2, 3, 4, 5, 6. One more. You got the idea?
Yes.
All right. So we have x. So this is x. And we taken 2. All right. So the objective is to have the x on the left hand side, right? On this one side. So in order to have the x on the left hand side here, I'm already taking these 2 tiles away. So how would I cancel out these two tiles? What do I have to add to these 2 tiles to get them 0, to make them 0? Remember, these are 2 negatives, right? So it means I'm going to add 2 positive tiles, right? So this is going to be a 0. And this is going to be a 0. And so the thing is, whatever I do on one side, I have to do on the other side. So these 2 are, so how many did I add on this one side? Azaria, you looking? How many did I add on this one side? 2 positive tiles? Mm-hmm. So if I add 2 positive tiles over here, well, then I have to add 2 positive tiles over there as well. So these 2 are going to give me 0, so you remove them. So put your 2 positive here. So these 2. And make sure you add on the other side. Because whatever you do on one side, you have to do on the other side. So take these away. So x equals, count up how many tiles you have there now. Those, just the ones on the right. 9. Right? So x is equal to 9. So what we just did here was x, sorry, let me use my black ink. So using the tiles, we have x minus 2 is equal to 7, right? So what we did, we cancel out a minus 2 by adding 2 on both sides, right? Is equal to 7 plus 2. So these 2 will cancel out to give me 0. So all I have remaining is x is equal to 9. Now, is it true? Is it true that when I take 2 from 9, I got 7? I get 7?
Yeah.
It is true. Make sense?
Yes.
Great. So this method here is called the inverse method. So if you're adding, what's the inverse of adding?
Minus.
Subtracting, right. What's the inverse of multiplying?
Division.
Right. So you got that. All right. So let's look at another case. So x plus 5 is equal to 9. So let's use our tiles. So you take an x.
Wait, this is positive.
Yeah, this is right. This is positive. So this is just an x. So it's not neither negative or positive. So this is an x. These are your negative. These are your positive. So to that x we're adding positive 5. So put your blues. Blue represents positive 5. Put it a little closer here, because these two go together, right? So on the other side, you're supposed to have 9, and 9 of the blue, because 9 is positive. Right? Do you have enough there?
Just 3 more.
3 more. We have 3 more. Hold on, we might need some more of these in the middle. Oh, we have 1 more blue. So what are we doing? So we need, you got 9? Great. So we need the x on the left hand side there, right? So you need to put the this 5 closer to the x. Right. Great. So we need the x by itself, right? So we are taking away how much? These 5. So remember, this is a positive 5, right? Follow?
Yeah.
So how do I make this positive 5 into a 0?
You take away positive 5.
Or I'm adding, or sorry, yes, I'm taking away 5, right? So my red tiles now are going to represent, so put 5 of the red, right, with this set. So these are going to cancel out. All right, 2 more. Great. Come on, 2 more. All right, so we know this is 0. So remember what you did on one side, you have to do on the other side. So how many did you add here?
5.
So do same thing on the other side. Good. So you have your zeros, 1 0, 2 0, 3 zeros,
8.
4 zeros, 5 zeros. So you're gonna have some zeros on that one side too. Right? Right. One more 0. Great. So x is equal to what? Count your blue tiles now.
4.
4. See that? X is equal to 4. So, and 4 plus 9 is actually, 4 plus 5 is actually 9, right? So you actually, so the algorithm would be x plus 5 minus 5 is equal to 9. So can remember we subtract 5 from the left hand side. So we need to take 5 from the right hand side as well. So these two 5s are going to give us 0. And hence we have x is equal to 4. Make sense?
Yes.
Great. So in essence, also there's a method called, so this method is called the right, this method is called the inverse method. All right, the inverse method, utilizing the tiles. All right, so without the tiles, let's say you have x plus 8 is equal to 15. What would you get without the tiles? 7. So x plus 8 minus 8 is equal to 15 minus 8. So you have 0. X is equal to 7. Great. So if I throw one of this into the back now, 3x is equal to 6. 3x is equal to 6. So we need to know what operation we have and then to do the inverse. So what is the operation between the 3 and the x? Multiplication. And what is the opposite of multiplying? Divide. So to remove that 3 there, what do I have to do on both sides? Divide by. Remember, yes, exactly. So 3x divided by 3 is equal to 6 divided by 3. So you can make your notes. Sure. Right, so these two will cancel out. And so you have x is equal to 2. Any questions?
No?
No? Great. So what about x divided by 4 is equal to 5? What is the operation involved there? Between the x and the 4? Division. So what is the inverse of division?
Multiplication.
So, right, so we're multiplying both sides by?
4.
4. Great. This is x over 4 multiplied by 4 is equal to 5 times 4. 2 4s will cancel out. So we have x is equal to, remember this could be 4 over 1, right? 20. Cool. All right. All right. So today we've looked at algebraic equations, and in an algebraic equation, in this particular instance, right, we had one unknown variable most of the times, but in the algebraic equations, you can have more than one unknown variables, right? And so so what is the difference between an equation and an expression? What makes them different?
Equations when you're solving the problem,
Mm-hmm.
and
The expression is,
to show how it's been done.
well, the expression you have you're either adding or subtracting between the, right? So an expression, like I said, x plus 3, that's an expression. So you notice there's an addition sign between the two. And with the equation, you have the equal sign. So you have equality, right? So the equal sign must be present for you to have the equal sign. So that's it for today. See you in our next session. Thank you for watching.